Then this one if you take, that is a 2 term, that 2 is coming, it is a quadratic actually. I will give you a small example, for this equation. Take for example m is equal to 2, that means my P loss, just hold on, my P loss is equal to, take m is equal to 2, I is equal to 1 to 2, sigma j is equal to 1 to 2, then Pgi, then Bij, then Pgj, right. So, when I is equal to 1, it is a 2 for loop actually, 2 sigma means 2 for loop. When I is equal to 1, you j vary from 1 to 2, that means what will happen, this term, right. When I is equal to 1, that is your Pg1, I is equal to 1, right, then j which will vary 1 to 2, that is B11, then Pg1, right, plus when your I is equal to 1, then your Pg1, then your B12, then your Pg2, right, plus when I is equal to 2, j varying 1 to 2, that means Pg2, right, then B I is equal to 2 means B21, j is 1, then your Pg1, then when I is equal to 2, Pg2, then your B22, I is equal to 2, j is equal to 2, then j Pg2. That means this is Pg1, it will be Pg1 square, right, B11 plus B12, Pg1, your Pg2, Pg1, Pg2, right. Here also your B21, B21, Pg1, Pg2 plus Pg2 square B22, right. Actually B12 actually is equal to B21, right, in general, right. So, if you take derivative, for example, this one I can write, then Pg1 square B11 and B12 and B21, if they are equal, then it will be 2 B12 Pg1 Pg2 plus Pg2 square B22. Now, if you take derivative with respect to Pg1 say, then it will be 2 term will come, it will be 2 Pg1, it will be 2 Pg1 B11, here also it will be 2 B12 Pg2, here also it will be 2 Pg2 B22. So, 2 term will be there. It is a actually it is a quadratic one, right. If you expand this and if you take the derivative, then you will get this one, right. That is why this, when you take the derivative of this term in general, this is a general expression, at that time there is no 2 sigma, because of the derivative only 1 sigma, right. So, it will be 2 will be common and j is equal to 1 to m, it will be Bij Pgj, right. So, that will be this equation will be, say this one, derivative one, if you take with if you take derivative with respect to Pg1, this one should not be there, because this will be 0, this should not be there, it should be, it is okay, it should be 0, I thought it is Pg2. So, it will be 2 Pg1 B11, I am just writing, say it in this case del P loss by del Pg1 is equal to 2 Pg1 B11 plus 2 B12 Pg2, right. So, actually it is Pg2, right. So, its derivative will be 0 with respect to Pg1. So, it should not be there, right. So, that is why this equation has become your j is equal to 1 to m Bij Pgj. If you want to check, you make m is equal to 2, then it will be your j2, then j is equal to that for say for I is equal to this thing for ith one, if say I is 1, for example B12, your Pg1 B11 Pg1, that is whatever you are coming to B11 Pg1 is coming, and then 2 is there, 2 B12 Pg2, right. So, this is actually your what you call this 2 term comes, right. So, equation actually whenever we are making all sort of things, right, if you are in front of me, then little bit of minor writing error, you can correct it to me, right, on the blackboard, but here nobody is here, right. So, so this one, that means this is your dp loss upon dpgi. Now, equation 55 and 56, right. So, this is your equation 55, this is your equation 55 and 56. So, what you do is this, you substitute this value for this one here, you substitute dp loss upon dpgi, you substitute, right. If you do so, this equation will become bi to di pgi, because dci upon dpgi is bi to d plus 2 di pgi, this one, right. Then this one, this term is substituted here, after that ith term is taken out. So, 2 lambda bii pgi, from this summation ith term is taken out, and that is why it is written, then 2 lambda j is equal to 1 to m, j not is equal to I, bij pgj, that is equal to lambda. That means, from this equation, from this summation ith term is taken out, right. Then from this equation you can write lambda, from this equation you can write pgi is equal to lambda minus bi minus 2 lambda, this whole term divided by 2 into di plus lambda bii. This is equation 57, this is equation 57, right. Now, at kth iteration, this equation 57 is expressed as, just put pgi k, just put pgi k here, this b d all are constant, right. That is equation 58. This is pgi k. If you take the summation of this pgi k, that will be your total load, and that is function of also lambda. That means, this pgi k, if you take a summation, that is summation of whole thing, right, a summation of whole thing. That means, that total generation at kth iteration, say total generation is equal to I is equal to 1 to m pgi k is equal to PL plus P loss k, total generation is equal to load plus loss, right. Similarly, substituting equation 58 in equation 59, that means, this equation pgi k is this expression, you substitute here in this sigma, that means, you will get sigma I is equal to 1 to m, this whole thing is equal to PL plus P loss k. This whole thing actually is a function of f lambda, because f earlier we have seen f lambda is equal to this one is equal to f lambda is equal to P loss plus P loss k also, right. So, this whole equation, this thing actually f lambda, right. That means, you need df lambda upon d lambda, that means, whole thing you have to take the derivative, right, because we have to solve iteratively. That means, that, and similarly, if this is also f lambda, summation of this generation is equal to PL plus P loss k, this is also f lambda, that means, f lambda k is equal to PL plus P loss k, the equation 61. That means, f lambda is equal to total generation, because this is also function of lambda, right. So, this is also function of lambda. So, f lambda k is equal to PL plus P loss k, this is equation 61. I hope you have understood this, right. It is mathematics, little bit you have to understood, right. So, when I will take the numericals, perhaps you will understand more, but look at. Now, question is, at any operating point lambda k, same as before, you expand it in Taylor series, right. That means, f lambda k plus df lambda d lambda, then delta lambda k, I am not telling again and again, it doesn't count, is equal to PL plus P loss k. Earlier loss was not there, now loss is included, and we have seen that delta lambda k is equal to Pg k, delta Pg k upon df lambda upon d lambda k, that also we have seen, right, and delta Pg k, right, is equal to, that means, this delta lambda k, this is also we have seen earlier. Therefore, delta lambda k we can write this one, this is equal to I is equal to 1 to m dpgi upon d lambda k. I mean, this is your, this whole equation actually, this whole thing actually your f lambda, right. That means this your, what you call, just hold on, that your, this is your delta lambda k is equal to delta Pg k upon df lambda by delta lambda k. That means, delta lambda k you can write is equal to delta Pg k divided by I is equal to 1 to m dpgi upon d lambda, because this equation if you look, right, this equation if you look, that it is basically summation of I is equal to 1 to m actually, right, and whole PGIK expression we have substituted here. So, that means this df lambda upon d lambda is nothing but I is equal to 1 to m dPGI by d lambda k, right. That means this delta PGK is equal to load plus loss minus f lambda k, because f lambda k is a your what you call that your function of all the generation, every iteration generation is changing, load is fixed, but loss will vary, right, because loss is a function of generation. So, that means load plus loss minus f lambda k. F lambda k is nothing but summation of all the generation at kth iteration, right. Loss is also changing at kth iteration, but total load is fixed, right. Therefore, this sigma I 1 to m dPGI by d lambda, that means if you take the derivative of this equation with respect to lambda, please you take this derivative. If I write the derivative, it will take another few pages, through another 2 pages. So, I do not want that, this derivative you please do it, right. So, what I have done it, this whole derivative actually I have written here, it will be di plus capital BII small bi minus 2 di j is equal to 1 to m j not is equal to I capital B I j into P G j at kth iteration divided by 2 into di plus lambda k B I whole square. This is equation 64, this is whole square actually, this is equation 64, right. That means, and that means this is known, this is also known from this equation 63 delta PGK known, and from this 64, right, this is also known, this is from 63 this is known, right, and from 64 this is also known. That means, you can easily compute delta lambda k in every iteration. So, once this is done, then delta lambda k plus 1 is equal to lambda k plus delta lambda k, this is equation 65. So, that means equation 63 actually, that means I told you this equation 63, it can be written as instead of f lambda k, you write PL plus P loss k minus sigma I is equal to 1 to m PGI k, that is 66. This process will continue till we get summation of this absolute difference, this thing of this one is less than epsilon, then solution is converged, right. So, that means once whatever we have done, that we have to determine lambda iteratively, right, and with loss and without loss. With loss things seems to be very simple, without loss things seems to be very simple, and with loss some more terms are added, that is a loss term, right. So, this is the thing. So, only there should not be any confusion. I repeat that f lambda, that is function of lambda actually is equal to PL, at the same time it is when it is loss is not there, right, at the time it is function of load as equal to generation, right. Both the cases f lambda is function of the sum of the total generation, right. Now, in an approximate loss formula, suppose it is given like this, approximate loss formula is given like this, say P loss is equal to I is equal to 1 to m BII PGI square, that is equation 67. That means is used here BIJ is equal to 0.0. So, no BIJ, only BII is there. Then equation 58 reduces to, that means in that equation 58 you please substitute Bij is equal to 0, but Bii will be there. That means Pgik will become lambda k minus Bi divided by 2 into Di plus lambda k Bii. Lambda k means lambda's value at kth iteration, right. This is equation 68. Then in the equation 64, that means this equation, that means in the equation 64, this equation your Bij term is not there, right. That means this equation will be simply di small di plus capital BII into small bi, right. The Bij term is not there. That means your this equation will simply become di plus BII into small bi divided by 2 into di plus lambda at kth iteration into BII whole square. This is equation 69. This is a simple example I gave. I mean, if Bij's are not there, right. So, this is your what you call equation 69. So, this is how one can find their what you call that your lambda values iteratively, right. So, let us take one example on this. So, fuel cost function for 3 thermal plants is given in rupees per hour. C1 is given this one 500 plus 41 Pg1 plus 0.15 Pg1 square. C2 is given 400 plus 44 Pg2 plus 0.1 Pg2 square. C3 is equal to 300 plus 40 Pg3 plus 0.18 Pg3 square, right. You neglect the line losses. First we will neglect the loss, right, and generator limit is also not there. We will consider in the next problem, right. You have to find out the optimal dispatch and the total fuel cost by iterative technique using gradient method. Total load is 850 megawatt, right, that is the thing. So, using this data, right, A1 is equal to 500, B1 41, D1 0.15, A2 400, B2 44, D2 your 0.1 and A3 300, B3 40 and D3 is equal to 0.8, right. Using equation 43, it is given Pgi k is equal to lambda k minus Bi to the kth iteration. So, assume the initial value, say lambda 1, when k is equal to 1, lambda 1, you assume the initial value is equal to 50, lambda 1, Bi and Di known to you, right, for all the generating characteristics that C1, C2, C3 is given, right. Therefore, using the initial values you calculate using this one, using lambda 1 is equal to 50, calculate Pg1, Pg2, Pg3 at the first iteration. So, right. So, in that case your Pg1 will become 50 minus 41 upon 2 into 0.5, that is 30 megawatt. Pg2 at first iteration 50 minus 44 divided by 2 into 0.1, that is 30 megawatt, and Pg3 at first iteration 50 minus 40 divided by 2 into 0.8, that is 27.77 megawatt. Now, you have to mismatch, you have to make it delta Pgk is total load minus total generation, this is the formula. So, at first iteration you find out what is there. So, in the first iteration when k is equal to 1, delta Pg1 is equal to 850 minus 30 plus 27.77, right, total load is 850 megawatt written here, right, and m is equal to 3 generators are there. That means delta Pg1 is equal to 762.23, large difference. So, you have to go for the next iteration. So, then equation 52 you calculate, use equation 52, delta lambda is equal to delta Pgk divided by sum of I is equal to 1 to m 1 upon 2 di, right. So, that means delta Pgk, it is m is equal to 3. So, I is equal to 1 to 3 1 upon 2 di, that is delta, when k is equal to 1, then delta lambda 1 delta Pg1 divided by 1 upon 2 d1 plus 1 upon 2 d2 plus 1 upon 2 d3. All these d1, d2, d3 values known, and from here your delta Pg1 values are known. So, calculate what is your delta lambda, right. So, in this case delta lambda 1 is equal to 762.23 divided by 1 upon 2 into 0.15 plus 1 upon 2 into 0.1 plus 1 upon 2 into 0.18. So, it is coming delta lambda 1 is equal to 68.6007. Therefore, for second iteration lambda 2 is equal to lambda 1 plus delta lambda 1. So, 50 plus 68.6007, that is lambda 2 is equal to at second iteration 118.6007. With that you calculate again Pg1, Pg2 and Pg3, right. So, second iteration lambda 2 is 118.6007, right. So, in this case it will be this one will be Pg1 to you calculate, substitute lambda, again you get 258.669 megawatt. Similarly, Pg2 at second iteration you will get, substitute lambda here, right, 373.0035 megawatt. So, Pg3 here you substitute lambda is equal to this one, you will get 218.335 megawatt. So, delta Pg2 will be 850, the total load minus sum of all the generation, we are getting minus 0.0075, right. That means, if you take the absolute of it, that your 0.0075 absolute of it, it is very small, and hence the solution and converge after the second iteration, right. And therefore, optimal solution will be Pg1 will be this much, Pg2 will be this much, Pg3 will be this much, and this will be lambda values rupees per megawatt hour, right. Therefore, that total CT will be C1 plus C2 plus C3, right. So, how much cost will be? Those Pg1, Pg2, Pg3 substitute in their expression and simplify, right. Then you will get this value, right. Just you substitute all these values, right, and you will get CT will be 69,481 rupees per hour, right. So, now we will consider the limit, we will consider the generator limit. Same example, but we consider the generator limit. So, Pg1 the minimum is 125 megawatt, maximum is 300 megawatt, right. Pg2 minimum 175, maximum 350, and Pg3 minimum 100, maximum 300 megawatt. So, you have to determine the optimal dispatch by iterative technique using gradient method, right. Now, same data, everything is same, example same data, but we will take this limit and we will see what is the change in the result, right. Now, question is that after second iteration of the previous example, that is example 5, after second iteration we got Pg1 250 megawatt, 258.669 megawatt, Pg2 373.0035 megawatt, and Pg3 218.335 megawatt, right. So, if you see that Pg2's limit is, lower limit is 175, upper limit is 350, right, but here Pg2 is equal to 373.033 megawatt, 0035 megawatt. So, we cannot take this value, we have to take only this limiting value 350 megawatt, right. That means thus this unit is pegged at its upper limit, that is Pg2 must be taken as 350 megawatt and is kept constant at this value. That means Pg2 you have to fix at 350 megawatt, you cannot take this one. That means this generator 1 and generator 2, this will be in operating, right, because their limits are not violated. If you do so, then what will happen after this second iteration, that just hold on, the second iteration, this the new that delta Pg2, the new imbalance 850 total load minus 250.669 is there. Now, we will not take this one 373, right, because it is pegged at 350, it is violating the limit. We will take this 350 only plus 218.335, these two are not violating the limit. So, in that case delta Pg2 is 23 megawatt. Now, equation 52, what we will do, this limit actually Pg2 has your fixed at 350. So, in that expression, that 1 upon sigma di, we will take 1 upon 2 d1 plus 1 upon 2 d3, but we will not take 1 upon 2 d2, because this has fixed at this limit. Earlier we are taking all the 3 terms, we are not considering the limit. Now, this generator 2 has your touch the limit. So, naturally 1 upon 2 d1 plus 1 upon 2 d3, 1 upon 2 d2 will not be there, because it has touched the limit. I hope you have understood this, right. That means delta lambda 2 will be, now it is coming 3.763, right. Therefore, lambda 3, lambda 2 plus delta lambda 2. So, it will 118, earlier it was converged at this value, now it will be 118.6007 plus 3.763. So, lambda 3 will be 122.3637, right. So, that means with this lambda you calculate your what you call third iteration, that Pg1, Pg2, Pg3. So, Pg2 is fixed at 350 megawatt, it will not change, it is touched its limit. Pg1 is 271.21 megawatt, right, its maximum limit 300, so not touched. Pg2 350 fixed and Pg3 is 228.79. His maximum is 300, so it is these two not touch the limit, but this is there. Now, you calculate delta Pg3. As soon as you calculate delta Pg3, it is 850 minus 271.21 plus 350 plus 228.79. So, delta Pg3 at third iteration is becoming 0. That means solution has perfectly converged, right. So, that means after third iteration, that your delta Pg3 is equal to 0 and the equality constant is met and Pg1, Pg3 are within their limit. Therefore, this is the optimal solution when constants are introduced for the generator, right. Therefore, Pg1 is equal to this one, Pg2 is equal to this one and Pg3 is this one, and this is the value of the lambda, right. So, only my request to you that look, so many calculations whatever you see here, all calculations actually have been done by me, right. So, if you find any error, any mistake, right, and anything calculation error or anywhere any writing error, right, please let me know this such that I can rectify these things. I repeat many times, right, because all these calculations I had to do of my own, right, and that is why I am telling you that I mean your cooperation is required when you listen this, right. So, next one we will take another example we will start, right. So, consider now example 4, we will take the example 4, right, with power loss expression. This loss expression is given, example 4 same data, but this loss expression we will take. It is P loss is equal to 0.00005 Pg1 square plus again 0.408 Pg2 square. This loss expression is given, that is B11 and B22. This B coefficient, other things all I will tell you at the end of the, I mean when this economic load dispatch will be over, after that I will derive for you, right. So, solution, this IC1 IC2 both are same earlier, we have seen that both are same data we are taking, and PL is equal to 370 megawatt, the same load, same data, right. So, that means B1 is equal to 41 and D1 is equal to 0.35 by 2, because when you take the derivative, this one actually it is B1 plus 2 D1, it is B1 plus your B2 plus 2 D2. So, 2 D1 is equal to 0.35, here also 2 D2 is equal to 0.35, that is why D1 is equal to 0.35 by 2, right. Similarly, D2 is equal to also 0.35 by 2, 0.175, 0.175, right. Now, this loss expression is given, B1 is equal to this much and B22 is equal to this much. Now, equation 68, right, equation 68, there we ignored that Bij, right, that Bij term we ignored. So, from equation 62 we get Pgi is equal to lambda at kth iteration minus Bi divided by 2 into Di plus your lambda at kth iteration into Bii, right. So, in this case what you have to do, you have to start some initial values of lambda. So, what you can do is you take lambda is equal to say initial value at it 60, that is lambda 1. So, with this initial value you get Pg1, substitute in this expression, equation 68, in this expression you substitute, right, then you will get Pg1 is equal to 60 minus 41 divided by 2 into all sort of things, right, that is you will get 53.37 megawatt, right. Similarly, Pg21 you will get 52.83 megawatt, right. Then power loss expression is given, you substitute Pg1, Pg2, you will get P loss at first iteration 0.3657 megawatt, right. So, once you get it, right, then you check the mismatch, then what you will get, that delta Pg1 is equal to 370 plus loss 0.3657, this is the loss minus the 2 generator generation. It is coming delta Pg1 264.1657 megawatt. This is actually too high, we have to go for next iteration, right, and find the delta lambda. So, from equation 69 we have I is equal to 1 to m, this value actually this is derived in equation 69. In this expression you put this lambda value, Bi's value, Di's value, everything for m is equal to 2, because 2 generating units you put m is equal to 2, right. You expand this term for I is equal to 1 to 2 and just put those values. If you do so, then sigma I is equal to 1 to 2, this will be this term, right, this one plus this one, these two terms. You substitute, all the values are known to you, substitute, you will get your what you call this 5.5511, right. Therefore, this is your this one, therefore, equation 62 delta lambda 1 delta Pg1 I is equal to 1 to 2 dPgi by d lambda at iteration 1. So, you have got this value 5.551, you substitute in the denominator and numerator we have got the mismatch 264.1657, that is actually is equal to delta lambda 47.59, right. That means, lambda 2 will become your lambda 1 plus delta lambda 1, right. This is 60 plus 47.59, so 107.59. So, for the second iteration this lambda value substitute in Pg1 and Pg2 expression, you will get 184.58 megawatt. Pg2 will get 181.34 megawatt, and power loss you will get the same expression, put Pg1 and Pg2, you will get 4.334 megawatt, right. So, with this, right, thank you, again we will come, right.